Advanced Maths, Paper 1, 2021, Question 10, Memo with Explanations. It's not going to help you very much merely watching this video or reading through the memo. You really need to practice yourself, so here's some suggestions for effective revision. Do not practice questions which you firmly know that you can do. Rather select the questions on topics where you know that you will have difficulty. The only time you start practicing full papers is when you're trying to reduce your time taken to do the paper. If you become stuck at a question, yes, watch the video. Then it's vital that you attempt the question yourself, preferably a day later, in order to test your understanding rather than your short-term memory. The very best way to revise maths is quality as opposed to quantity. It's more effective to complete fewer revision papers completely and correctly, ultimately without having to refer to help of any form, than to complete as many papers or exercises as possible. Confucius says, "What I hear I forget, what I see I remember, what I do I understand." So now we have to sketch a variety of graphs. Y equals the absolute value of sine 2 theta. Well, the graph y equals sine 2 theta looks like that. Starting at 0, amplitude 1, period pi. Notice because the period is the normal period for sine theta, which is 360 degrees divided by 2, 180 degrees, or the normal period 2 pi divided by 2 is pi. So there it is. Now y equals the absolute value of sine 2 theta means it's y equals sine 2 theta for sine 2 theta above or equal to 0. So when it's above the axis, when this is greater than or equal to 0, then this just remains. But when it's negative sine 2 theta, when it's negative below the axis, then you've got to change to negative sine 2 theta, or in other words, change its sign. So we change the sign of that, so in other words, we reflect it through the x-axis. And there is our graph of y equals absolute value of sine 2 theta. Let's sketch the function y equals ln absolute value of x. It really is important to go back to the definition of absolute value. Notice I did it here to explain, but you could probably do it without having to go there. But when you have the absolute value of x within the equation, I think it's better to go back to definition. So there's y equals ln x, y equals ln x. Now y equals ln x is ln x for x greater than or equal to 0, ln negative x for x less than 0. So that's fine, x greater than or equal to 0, there we are there. But the graph y equals ln negative x is a reflection of that here. And when x is less than 0, we have the reflection. So this reflection is also part of this graph. So there's our graph of y equals ln absolute value of x. Okay, here we are below. Solve the inequalities. Absolute value 2x minus 4 less than or equal to 8. Well, first we'll determine which graphs to use. We've got absolute value of 2x minus 4, so therefore we know it has to be this graph because it has the absolute value of 2x minus 4, except it has a minus 2. Establish the exact equation of the one of the graphs on the left. So have a look here. I have 2x minus 4, so I need a minus 2. So I'm going to put a minus 2 there, which means I must put a minus 2 on the other side. So therefore, I end up with minus 2, and that becomes 6 there. This is still this inequality. Now, in this case, we need y equals 2x minus 4 absolute value minus 2, this graph here, to be below y equals 6. Y equals 6, y equals that. So there's y equals 6, there's it's below, and there the x values. From there to there, we have to give the x values from there to there. Because it's or equal to, we include those n values, so there we are. So x goes from -2 to 6 inclusive. Twice absolute value of x minus 2 plus absolute value of x plus 2 is less than or equal to 10. Here all we can do is hope that it doesn't get too complicated. I'm going to take one of the graphs, so I'm going to establish one of the graphs. So absolute value 2x minus 4 minus 2. So I'm going to establish that on the left-hand side. So that multiplies in to absolute value 2x minus 4. I can do that because that's a positive number. Minus 2. I'm going to take this one to the other side. And then to get the minus 2, I've subtracted 2 there, so I must subtract 2 here. That is still that equation. Have a look. Take out the 2, 2x minus 2, plus absolute value of x plus 2. That minus 2 goes to that side, 10. So I now have an equation of a graph I've drawn. And luckily, that is the other graph, which is exactly what I need. So, where is that graph below that graph? Well, there. -2,7 to 4. That's an approximation. I don't know if it's correct. It might be -2,6. If you want to be exact, you could equate these two where both are positive because, no, but we'd have to change the sign of both. But never mind, I'm not going to go into that. All right, so it's that section there, or equal to, so therefore it includes those endpoints, and therefore there is our inequality there. So the solution.